Hey everyone, welcome to my YouTube channel Code with GT. I am a software developer and I have been working in this field for over 5 years now. In this YouTube channel, we discuss programming concepts to help you become a better developer. So without further ado, let's dive right in. In this video, we will look at what are types in TypeScript and we will know more about types. What is a type? In TypeScript, type is referred to as any convenient way to refer to properties and functions that a value has. So every value in TypeScript will have a type associated with it. You can consider type to be a label that is attached to a value. Let's say a variable has a value hello world. How would you describe it? So we can say that it is a string, right? But it will also have certain properties like string.caret and concat to combine two different strings. Now these functions are associated with this value. When we want, so the way to describe all these properties this value has, we give it a label which is string here. So that is what type is about. In JavaScript we have two types of types, primitive type and object type. So the primitive type examples are number, boolean, string, null and undefined. These are what is initially present in TypeScript. And the second is object types. We can define these types and we can change the values in each of these types. Both of these play a crucial role in development in TypeScript. For example, if you remember in the last video where we wrote our first TypeScript code, by the way, if you can check out the video here, you will see a link above. Let's go to the previous code. In this code, we defined this variable data with user detail and we had mentioned some types in user detail. So this is a way to assign type to this data. The other way could be we could directly write this object in place of user detail and it would still have worked, and this will also work and it will not throw any error. But every time you would want to refer to data, you would have to write the entire object. Creating an interface and assigning the type is a good way for any big JSON. Now let's say we wanted to refer to a different property in data. So for example, if I write data dot maybe address, I get an underline because we typed data as user detail and user detail doesn't have an address type on it. So the editor gives us an underline. This is exactly why TypeScript is used, to help us point out the errors. Now if I know that data has a property called address, I can change the definition of user detail and add address here, and this error will go away. So let's look more on how editor looks at the types. So I will create a new file here. I will call it types.ts, and let's say I create a variable constant. I will write hello, string equals hello world. Now next time I refer to hello, the editor knows that this is of type string, so it will suggest me the functions which are associated to the string. For example, I can change it to lowercase, I can find the length with this, and so on. Let's create a object here. I will create const my object equals. So I write a parameter param1 equals 56. So you can see my object TypeScript defines its type with a JSON object, and it lists down the parameters. This is because we don't have any type associated with it. Now let's say we would have created an interface with these properties, then TypeScript would have identified this as the interface which I had created. Similar to here, like we had created interface user detail, and if we hover on data, TypeScript knows that this is of type user detail. Next, I create a class my class equals article and write id, and then I create an object of my class, new my class. Now TypeScript knows that this is of type my class, and I can refer to properties of this my class object. But if I try to access any other property like random, since random doesn't is not present in my class, we see a red underline here. So what are types used for? It is used exactly for this purpose, to help the editor help you to see the errors. And secondly, if you mention types after every variable you declare, it will also help other developers to understand the code better and understand the intent of why the variable was declared. Now let's look at type annotations and type inferences. Type annotations are a way to tell TypeScript what the type of value is present in the variable. So in type annotations, you manually specify the types. And in type inference, you assign a value to a variable and TypeScript tries to find out what type of value is present in it. So let's see with both of these with an example. Okay, let's say I create a variable num and I say that this is of type number. Since I explicitly told TypeScript it's number, it is a type annotation. Let me assign a value 34 to it, and so now TypeScript knows that num is of type number. I can assign any other number to it as well, like 100. But if I try to assign a string to it, my string, TypeScript throws an error, like tells me type string is not assignable to type number. If I want to assign a string, I will have to create a new variable. Let my string of type string equals my string, and this is acceptable. When a variable is initialized, TypeScript has to know what its type annotation is, what its type is. The types can be of any of these types. It can be number, boolean, string, even null and undefined are acceptable. This is of type boolean. This is an object of the date class. You can see there's an interface date and it can store date in its format. We can also create a variable of type null. So like that. The variable null can only contain null, it can't have any other value. We can also make it undefined, and undefined is also acceptable. This is how type annotations work. These were simple types of type annotations, but these can be even more complicated. We can assign type annotations to arrays or functions or objects. To create an array, I can just write let, maybe I want to create a string array, my string array. I will have to assign the type annotation, which will be string, and this will be an array, and this equals. So this is how we define string arrays. Similarly, we can create an array for numbers. This is a numbers array, and same for boolean as well. So how would type annotations work with classes? I can create a class. Maybe I will name it my class. And if I want to create an object of it, I can assign this type class to a variable. So this is where I'm creating the object, and this variable has a type of my class. So this will be the type annotation for this variable. Now let's say we want to create a simple JSON object, and how would type annotations work for that? So let's say I have a coordinate, and the value of the coordinate is x is maybe 12.0 and y coordinate is maybe 10. To assign type annotation to this, I can write as colon, and in curly braces I can write x should be a number and y should also be a number. If I try to assign string to y, maybe 10, I will see an error. So this is similar to how we can't assign a string to a number, here, this won't work because it's in double quotes, it's a string. So similarly, this should be a number. And this is how type annotations work for classes and random objects. So let's look at how to assign type annotations to a function. So let's say I have a function, my function, and it maybe takes an input of type number, and I can console log this input. Yeah, so this is my function. Everything after equals to is what will get executed. This number is the type annotation for this input type, but we also want to define what the output of this function would look like. So that function definition comes here. So we tell TypeScript here, like we will have input. So this will be one parameter, and then our output will be of type void. And we use colons to tell TypeScript that this is the type annotation. So void is also actually a primitive type. That's how we assign type annotations to functions. Now there's an interesting thing here. If we did not mention number for num, or string for the variable myString, or even boolean for myBool, TypeScript would still know that boolean is of type, the variable by myBool is of type boolean, and similarly the variable myString is of type string. How does this happen? This happens because of type inference, where we saw that here TypeScript will automatically figure out what type of variable value is assigned to the variable. So when initializing a value, we have two parts. In the first part, we name the variable, and in the second part, we add a value to it. Now in this case, TypeScript will know that the type of my var is string because we are assigning a string to it. But what if we don't assign the value here and we assign it in the next line? In this case, if we hover, we see that TypeScript sees that my string is of type any, because TypeScript doesn't know what type of value this is. So this is how type inference works. So it will only work if initialization is done on the same line. The obvious question is when to use type inference and when to use type annotations. When to use type inference, the answer is simple. If we are initializing a variable in the same line where it is declared, we will use type inference. We will let TypeScript decide the type. The benefit is we will have to write less amount of code. And when to use type annotation? Well, if a function returns a value of type any, we want to type these results, so at that time we will use type annotation. For example, I have a function, my function will, let's say, return an object. We'll have a key value pair, and let my receiving var, let's say it wants to parse it. So I will make it return a string. Yeah. The receiving var is of type any. But that next time a developer wants to use this variable, he won't know what type of value this contains. So it will be very difficult for him to go in and check from where this variable is receiving the value, then write his code accordingly. So it's better to define its type, which will be key. This will be of type number. So now we know what type of receiving var this is, and next time a developer touches this code, he will know that this is of type key, like it is of type JSON, and he can directly use this object for his further computations. This is how we make use of type annotations and type inference in TypeScript. We saw that if we don't initialize value in the same line, TypeScript takes it as a type any. To solve this, we can just add a type annotation here that number is of type num, and the warning which we got here will go away. We want to create a variable. Let my var new equals to false. Now type inference would see that my var new is of type boolean. Let's at a later part we want to assign a number to the same variable equals to 23. Now TypeScript won't allow us to do that because we had defined my variable as boolean, like TypeScript assumed my variable will be boolean because of type inference. So in this case we can actually assign a lot of different types of types to a variable. So for example, we can say my value is a boolean or it can be a number. So if we know that in future, in the later part of our code, my variable can have different types, we can specifically mention those types at the time of initialization. So that's how you can assign multiple types to a variable. We also have a type never in TypeScript. So never is used when with a function if we know that the function is never going to return anything. So let's say I have a function, my function never, and it doesn't take anything as input, and the return type will be never. So never doesn't mean it is not returning anything, because if a function is not returning anything, its return type is void, which we saw before. Never means the function execution will never complete. So this is typically the case when we want to throw errors. This function returns throw new error. We can like name it message. Now if this error is optional, like for example, if let's say it takes an input I as a number and I as a number, and let's say it takes, if I less than 4, I want to throw an error. Now here never becomes a problem because if I is greater than 4, then the function will complete. So maybe it returns something like 12. In that case, we should mention the return type as number, and if I is less than 4, it will still throw an error. So never is used when we definitely know the function execution is not going to stop. Now let's look at how we destructure the type annotations in a function. For this, let's take the example of the coordinates object we had. So let's say I have const coordinates equals the x coordinate may have a value 10, y will have a value of 40, and I want to write a function to print these coordinates. Const print coordinates equals, it will take the coordinates class as input coordinates, and it has a structure. Let's say x is a number, y is a number. Now since we are printing, it will have a return type of void, and let's write the print statement here. Console.log, I will write here, can name it my coordinates, and I have to write, to print the x coordinate, I will write my coordinates dot x Similarly, to print the y coordinates, I have to write my coordinates dot y. Now every time we have to use a value in the object, I have to first mention the my coordinates and then the property on it. So is there a simplest way to do it? Well, yes. So in place of my coordinates, I can directly use values here. Like I can write x comma y, and then in the function inside I can just use the properties. So x corresponds to a number, y corresponds to a number. So we destructured the type annotations and the property names. So this is how destructuring works in TypeScript. Let's look at another example of destructuring. Let's say I have coordinates object. I want to add another property, country. We'll set it to India. If I want to change this value of country, I can do coordinates dot country equals maybe I can assign a name Bharat. So this is one way to do it. The other way to do it would be I can create a function inside this object, set country. It will take country as input, which will be of type string. Return type will be void. This dot country equals country. This is how I can change the value inside this object. Now let's say we want to extract country from this. So I can write country. I have to mention the type. Country is of type string. This is equal to coordinates. So this way my country variable will have India stored, which is present in coordinates. If I want to extract x and y, I can do it similarly. Now x was a number and y is a number. Here's how I destructured these variables, similar to how we did it in the function. So that's all for this video. Thank you for watching. If you liked the video, don't forget to subscribe to my channel Code with GT. Hit the like button and share this video with your friends. Happy coding. Bye bye.